a quick disclaimer. I'm not a DBA, so if you see something stupid or obvious, things that need to be done the right way, just call me out. I'm a Django. I hope I'm Django. But and if you see anything in code issues, because I did that within the last 2 days, just more than happy to do a pull request, modify the code, and upload it. So just put it out there. So searches everywhere, right? So one of the expectations that we had from our platform was the students were supposed to search for content. So it could be for students who are taking the same classes or courses, or searching for research articles or some of the recommended reading the professor has given out. So it's pretty dense searching that was required for there. And it was a full text search, so you can put in just simple English like, Professor, Captain Kirk did this specific topic. So you want to actually search and give English-like search keywords, just like how you do it in Google. And you want some linguistic support. You want ranking. So basically one of the requirements was that they wanted articles to be the ones that were the latest come on the top versus ranking on articles that are old to be on the bottom. So that's something that they wanted. And then there's a fuzzy searching, which is basically if you typed in spelling mistakes, it should still give you results, at least the later results, not necessarily exact. And lastly, more like this. So if I looked at an article, which you see this every day, and I spend hours on it, if I see a video on YouTube, I end up going through 10 other recommended videos, and by the time it's 2 hours. So something like that. We needed that in our platform. So we had all these requirements, and the time to market was everything. So we wanted to see, okay, what can we do at least to start off? And we have these options, basically, which was Solr, Elasticsearch, Cloud Search, and Sphinx, and you name it. But the time to do all configuration for these is just a long time, right? So I mean, Solr itself, it's Java, so fuck Java. And then there is Elasticsearch, which is actually pretty good. We are moving towards that. I would highly recommend you guys look into that. And then there's Cloud Search, which is pretty interesting. It's a little expensive, but it really does take care of all of your search needs. And I'll kind of come back to that in a second. And Sphinx, I don't know a lot about it. It's there. It's written in Python, so if you are brave enough to go check it out. But all of these required some degree of knowledge of those tools. And we were pretty good with Postgres already. And we knew that Postgres offers some degree of search. So why not just try it out? So, so just going back to this slide. So we know in Django, most people use iContain, which is a dumbed down version of search, right? I mean, that's a very kind of go-to phrase for that. Searching across the tables is really a pain, and you cannot really control. I mean, if you control it, you end up writing your own custom SQL. Or the ORM takes care of all of the joins. There's no relevancy, no ranking. You can't do fuzzy searching, so it's just basically limited. You just shouldn't be doing searches in Django, or for that matter, straight up Postgres searches. So what we did then is we looked into Postgres, and thanks to Russians, some of these search features are amazing. They're all written in C. They're really good extensions. And we were pretty amazed how fast Postgres is compared to Solr, compared to other search engines. And so we started going into that. And once you go down the rabbit hole, you end up finding more and more new search features and be like, okay, at this point you're a Postgres shop. And you end up giving a speech of Postgres. So that's something that we looked into. It's really fast, very, very simple to implement. If you've already been using Postgres, this should come very natural to you. And on top of it, it supports ranking, boosting, fuzzy search, and the list goes on. And they continue to add new things. So please check out the latest versions on some of the great fuzzy searching algorithms right now. So, live example. Let's try to find that if you can find it. There we go. So I really stripped this in like a few hours. So sorry if hopefully it makes sense. So this is a simple search. What I have is a bunch of students taking Python or Java, and basically I took all the users from Stack Overflow. So this is a very small subset. So I recommend that you take, if you have time, download the code. You can download the users from Stack Overflow, which could be in millions, or you can actually take posts, which could be in millions and millions, and upload that. So I have scripts that can upload Stack Overflow data, so just run it, and you can test it out yourself, right? And then, so it's a simple search. I give an options. The good old search is, which is a like clause. You can see on the right. Then you got the full text search, fuzzy search, and sound deck. So a simple thing like David, I want to search for that. Pretty fast. I have about like almost a million records in there, and it took about 0.79 milliseconds, literally. That's fast, in my opinion. So, and it's doing it across tables too. So you can see that actually David is a username, Python is a course name. And if I do it like, it's about 2.8 milliseconds. It's still fast, but you can see the difference between, I don't know if you guys can see that. Can you guys see it? All right, good. So the difference is pretty drastic when you do a simple like. And that like looks ugly, so I'll show you in a minute. But just the full text search is pretty dopey fast. And the other things you have noticed, one thing is that I'm ranking it by Python. So all the guys who are taking David and enrolled to Python are coming on the top. If I change the ranking, I'll still get David, but I'll get Java boosted on the top. Does that make sense? Right? So if you look at the bottom, you will see guys who are initially were on the top, now at the bottom because I ranked them differently, but they still master the results. So this happens all the time. In our platform, we need to show users that are ranked by if they are taking English and they are at the mid-level English reading, we need to show them boosted results which are, catered to that specific core curriculum. I don't know whether you know anything about education, but the point is that we need to show data relevant to their profile. So it could be any profile. In this case, if I'm a Java person, I want to rank them by Java. So that's a simple search. Going back to any questions so far?
Are you using any messaging queue like Serum queue or Alarm queue to quantify the speed within the search?
So this whole project is basically, this is an AngularJS project. So it uses AngularJS in the front. All I have is an interceptor that actually makes a call. Every time you make a HTTP call, it just calculates the time taken between the requests. So that's all it does. All right, so why are you doing this to me? Okay, there we go. So yeah, so that's just sort of thing that I kind of talked about, and then I'll come back to this and this. But the last point is that the table, think about the table, the way we structured it is very similar to a search engine that you're going to use. So for example, if you're using Solr, or if you're using Sphinx or you're using Elasticsearch, you have to create an index, which is a very common thing. For anything you're going to do, you need an index. In the similar manner, you need to update that index. Every time there's a new record that's been added, let's just say someone adds a new student, someone adds a new course, some student enrolls a new course, you do not want to update on the main thread. So if someone says, I don't want to take that course anymore, you want to do it, you want to offload that work to something else, because trying to update a table and trying to update the index will take forever. It doesn't matter if it's Postgres, it doesn't matter if it's any other index. So always use Celery. Actually use Celery for everything, if possible. It's good for health too. But the point I'm trying to make is that you want to offload all of your large tasks into something like Celery. Does that make sense? Okay. So what Celery does is it updates the search table so that it's available for searching. The only downside with this is that the results are not going to be latest. So if you just enrolled and if you search for your name, you might not be available in the search result, which is a common theme across all search engines. Whether you take the best search engine like Google, you're not going to see the latest results right away. It'll take some time for them to index it. Okay? That make sense? All right, good. So before I go into the whole idea behind what's happening in Postgres, I just want to highlight some indexes. So the two indexes we're going to use today is Gin and Gist. Let's talk about Gist for a second. So the way Gist works is if you take a document could be simply a name of the person enrolled for a class. It breaks down individual words into hashes of their own, okay? And then it ORs them to create a big string, all right? So that's basically what hash-based Gist index is. Gin, on the other hand, uses B-tree. How many of you actually know B-tree here? I would love to know. Wow, there's a lot of people. Awesome. A B-tree is a shallow tree, but it has a wider width, right? So the reason why it does that, can anybody tell me why it does that? Like, why isn't it like a binary tree, which can go as long as possible? Why does it go wider, but not in vertical? Like, it's very shallow. Anybody? Everybody raised B-tree, they knew it. Come on.
Weekly.
Research, I mean, are you asking for to shorten the trip?
Right, so that's binary tree does that too, right? But binary tree can go as long as possible. But B-tree,
B-tree has the...
right, so B-tree is very shallow, so it'll only try to do nodes horizontally. It will never go vertically up. The entire CouchDB, how many people know Couch? CouchDB? Yeah, it's all based on B-tree. Basically, it's literally a B-tree. The reason is because when you take a B-tree index, the biggest problem with any disk is that it tries to seek a sector, right? So when you try to read a sector, that's where the most time is spent, right? So if you can make the index, or at least you can make that node as big as the sector itself, when you read it, the whole node gets loaded into the memory. From that point on, it's extremely fast to seek that node. Does that make sense? So if you go vertical, you can't do that, because then the nodes will be spread out onto multiple disks. But with a wider node, you can actually put that entire thing on one sector. It's just much faster to access. Does that make any sense? Or just assume it's fast, okay? Just take that from me. But so with these things, you get, but the problem with the B-tree is that the update time is a little longer, because since it has to really update the entire sector, it takes a lot more time than just. But you get 3 times more speed. And then the size is the same thing, because you're getting a bigger size. So, for the sake of this argument, just use Gin. Just don't go to GIS. It's just much easier to use that. So, there are certain things I'm going to introduce into context here, but do not be afraid. This has got nothing to do with Postgres, but it's just the way any search engine works, which is it takes the words, the document that you give it to it, and it stems it. Basically, just make sure that it normalizes the text. What I mean by that is you can see this text, how much would Chuck would. I could never say that, no matter how many times I tried. But the point is it will normalize that text. So you can see here, it will remove stop words which are such as, it will normalize those words. It will remove, it will convert them into lowercase. It will singularize them, and it will make positions available, which is very common concept called stemming, which happens in every search engine. Okay, so if you ever looked at, can you guys see this, or is this too far away? So it just takes a bunch of words and converts that into a search engine concept, which is called stemming. And if you look at Solr, if you look at Elasticsearch or Lucene, which is where it all started, it will do the same exact thing. Okay? Any questions? Good. What are you talking? I'll get some water.
Somebody's downstairs. The guard won't let them up.
Neil, somebody's downstairs wants to get up and being blocked by.
Sorry about that.
No, it's okay.
I just happened to be paying attention.
Yep, thanks. So that's what he does. So we need to do that. Just like how he would do with any other search engine, you're going to have to do it. And then lastly, when you search for something, you need to convert that search term into the normalized text. So you can see here, I don't know whether anybody see that, but basically what you did with these documents, you have to do with the search query also. But this is just information is good to know. You're never going to ever have to write this. In the sense that this is done in a very good package called Django ORM, DJ ORM, so we use that. This is just to make sure that you understand what's happening. So once the data is converted, and can anybody tell me what this is? Just curious if you notice something. There's numbers associated with that.
Index of the word in the sentence.
I'm sorry?
isn't it the index of the word in the sentence?
Yeah, so it's positions. Yep. So basically just saying that these words are there at that positions.
What if it were like plural? Does it care about singular, plural? Or
Yeah, so it converts everything into singular.
Wait, so how is not included?
Yeah, so those stop words are not included. So it uses a dictionary of English dictionary, or you can actually convert that into a specific language. So it has multi-language support that I forgot to mention. So if you are French speaking, you can still use this. But yeah, so it singularizes that into Word.
Okay, thank you.
Fine. So you can see here at the bottom, I said Chucks, and it will singularize that, and then we'll make sure it'll map that to, it'll give you true for that. But you have to convert that into, normalize that as well. That makes sense?
Did it normalize it? You wrote Chucks, but if you wrote Chuck, would it still find it?
So if it showed Chuck, yes, it would. But you need to convert that because it's, if you want to just make sure that if you're using any plain English term search, like if say we did woodchuck chuck, then you want to use that TS query.
It works both ways. So if you have plural in the sentence or plural in the search,
Yeah, it doesn't matter what you put in here, assuming that
it will singularize.
Yeah, singularize it.
Yeah.
So yeah, so I mean, you don't really need an index, but you always, the large tables will be very slow. But if you want to ever run a select statement, you can just do that. This is a very straightforward thing. So what we do here is we're going to create an index. We can actually create an index based on just a few columns. You can see here at the bottom, you can actually take 2 columns. You don't have to do it one column. So that's the beauty of, that's called document. So if you'll notice that when you're using any of the search engines, they'll ask you to create a document, which is a composition of multiple fields, like a first name, last name, their age, or whatever you call it. And then that becomes a document. You can actually do that right here, which is awesome, in my opinion. So, so we'll just quickly look at that code. What I just talked about is basically that search right here, which is, so I'm using South. How many of you actually started using is it 1.7 that has the migration thing now?
Yes.
How is that? Is it fun, or is it just a learning curve, or how many people have used it so far? At 1.7.
Is it different than the external South? Or
Yeah, I don't know because I
It's
haven't
based-
even looked at it.
based on South, but it's based on South, but I'm not sure.
Is it? Okay. So I'm using South. I love South, but so it's so the basic idea is that you create in South, you just simply create an empty migration, which is, you probably have done it 1,000 times. And what you do is you just basically add a field like that, which is basically DB execute, and you just say the table that you want it, and then the column name that you want to put an index on. That's all, which is not that complicated. And then all of the work happens here. So just want to make sure that.
from your models?
Sorry?
You can't do it from the models?
You can. So DJ. So the reason I'm doing it raw because I wanted to show how it looks like. But if you use DJORM, they actually do that automatically behind the scene for you. So, and I highly recommend using. I have a slide on that, but you can actually create, and then I'm going to contribute to it too with the whole fuzzy searching. But it has a field called vector field, which converts that into the proper Postgres field.
So are you indexing right on the models that are going to be searched, or are you kind of combining models into some other model that just have one big
That's a
table?
great question. So if I just show you the model for a second, I like this. So this is a model that I created, which I call the document, if you may, right? So you don't have to create it. You can actually still use an existing, a model that like a student in the course. But what I wanted to do is I wanted to create a model called Student Full Text Search, which is basically is a list of 3 fields. One is the student. This is a one-to-one field, which we already know. The title, and we'll come back to it in a second. And then the field, the searchable field that we just talked about, which is the actual document, which contains all the concatenated data that you want to search for. So you can concatenate anything. You can concatenate the name of the person, the course, their age, their location, you name it, right? So it could be anything. And you can have as many fields as you want, and you can create individual indexes on that. So you can, one model can actually have 6 fields, 6 different documents, and 6 different indexes on that. It's perfectly okay, right? So you can have n number of fields that can be searchable, and you can use all of them. That make sense? So how do I, so I have, if somebody signs up and some student signs up for a specific course, how do I update this? So basically what I do is I use Celery. And basically I try to give as many comments as possible, so hopefully it does make sense. But all the Celery is doing here is basically updating the table at the end. So it is preparing the document DB. So this is this document. I don't know whether you can see that, but
Can you zoom in make the text?
yeah, I'm trying to figure out how to. Where do I go?
View, maybe?
That's
Display?
Command plus?
Yeah.
Yeah, just try that now.
That worked.
Good? Is that good enough? Or
I thought a clip could make it bigger.
you'd be amazed how small I keep my fonts. But for more space, I guess. Display one last time. And display. Hopefully it shows up.
Holy
Nope.
That's worse.
That looks really awkward.
it was better.
That looks awkward.
Is it okay, or should I just go back what it was?
It's
Alright.
worse.
Okay.
At
It's
least
worse
the
than
other
mine
one
did.
was stretching the screen. This is.
All right. Next time we will give binoculars to everybody in the room.
There we. That's good enough.
I wish I didn't know how to. This Eclipse. I don't know
Oh,
how to-
hold down the function key and the one next to it, and then
Function plus maybe or function.
I
No,
tried it.
no, you zoom with the trackpad. You hold down function and the key next to it, and then you zoom with the trackpad.
I'm such a dumbass
Finger
here.
upward
Um,
on the trackpad
Who
as you
knows?
hold function.
What's that?
As you hold function, move your fingers up.
Yeah, I tried to do that. Do I know?
Multitask.
2 fingers.
Yep, I have 2.
You might
No, it's fine.
pinch to zoom maybe. Okay, that quite
But,
almost.
Almost.
sorry, little
It'll work.
squint, I guess. But what I'm trying to do here, all I'm trying to do here is I'm actually preparing the document itself. So you can see I'm doing first name, last name, and the course name. You can put anything you want. You can put any document concatenation you want. Like anything that you want to be searched on, you can concatenate that into a field. That's all you need to know. That's all I'm trying to show. It's a simple join at the end. I'm just joining that into a string. But the idea behind it is you create a column, which is a TS vector. You add the fields that you want to get searched on, and you create an index on that. That's all you got to do. It's that simple. And when you look at a code, it'll be pretty evident on that. And you do a search on that field. That's all. So Celery does a very good job out doing this, but why do I have to do this? Which is, why do I have to set the transaction dirty here? And if, I don't know if you can see that. Can anybody tell me that? Why do I have to set the transaction dirty when I'm actually running an update statement in Django?
You're out of process here.
No, I'm just still running Celery, right? Celery runs under, so I'm almost like a management command, right? So it's loads up a different process, loads up the database, loads up everything as if you're running a management command. It's just that it happens to run in Celery. And Celery, if you look at the if you look at the nope, that's not it. This is your Celery file, and all you're doing here is that you're just saying start a Celery and look for all the installed tasks, and you're just passing in the settings file. That's all you're doing, which is really running it as an admin command at some point. I mean, I'm oversimplifying that, but I have to do this for some reason.
it locking the database?
Nope. It's because you're running, when you're running the cursor, I don't know how many people notice that, but when you run a cursor, and anytime you execute something, you have to set it dirty because you let Postgres know that you're updating something. So because you started a transaction here. Okay, when you see a transaction and commit here, it starts a transaction, but you updated something onto Postgres, and if you don't issue a commit after that, you're going to end up having a situation where it's going to roll back automatically, or it's going to throw an error, depending on how you set the Postgres setting up. So, but the reason we want to do this is because we want this to be atomic. We don't want halfway through this and fails, and then be like, oh shit, the database, the search is corrupted. So we want this to be atomic, but since it initiates a transaction, right, a new transaction, you need to finish that before you leave. But the cursor has no, Django has no idea that the cursor executed because it has no, concept of oh, I gotta commit this. So that's why you need to set that dirty, because none of the models, in here, there's no model here. I don't know whether you can see that, but there's not a single model that has been set to dirty. And that's why you need to force feed it, saying, you're dirty, go commit yourself. Does that make sense?
Well, why not do it the other way? Just do a manual transaction and do your own commits.
Manuals, can you elaborate that a little bit?
Just transaction commit and say.
You could do that too, yeah.
Instead of commit on success,
so
like a manual.
you put that in a, you could put that in a try catch block, right? So you do a try, you say transaction initiate, right? And then you do success on the right before the accept, and then in the rollback. So you can do that too. It's just, the reason I'm doing this is because.
But you don't want the roll. I mean, do you want a rollback ever?
Yes, because you
want for each one, like.
Yeah, because you're trying to run this anytime a student course happens, right? So the way you call that is from here, which is right now while I was uploading data, you can see I'm calling it as a delay. So the task, that delay, which pushes the task
Celery.
onto Celery, and now at this point it's completely different transactions. Okay, cool.
Another question, could you call save on the model in that?
You could do that if you can force a model, like change something in model and save it. It will then automatically understand that there's a dirty flag set, and they will do a commit on that.
So none of the fields that you touched in there.
Exactly, because it's a direct update to the database. Literally just a cursor update. So when you, so basically what I did just now is, so again, running through the thing, you create a model, which is a brand new model, which is pure text for searching purposes only. You create a field that actually can store your concatenated set of fields that you want to be searched on, and you create an index. Once you do that, basically that forms, and then you write a Celery task that can update it. And then at the last you do is you basically do a search on the term itself, which is this, where column name, this is a special Postgres sign called plain to query, and then you search for that. And that's it. And you're going to get all the rows that match that specific query. Any questions? And you do that with the model here so that you get the models back. So you don't have to use a cursor here. You can just use a model.extra. That way you get actual models back in your query. I see some blank faces, so I just want to make sure you guys are. It's not database. I know it's a little bit database heavy, but I just want to make sure that you understand the fundamentals, because if you start using Django ORM, you don't have to deal with all this. You basically, the way you deal is the model.search, give the search text, .rank, I'm hoping to add that, and you basically just work as if you're working with models.method name. You never have to do this again, because there is already a package that does that. So I just want to make
code that does not use it.
Yeah. So I have. So let me just. What I'm saying is,
Oh,
Yeah.
that's really cute.
So that would be something like you would create, like you create a vector field that I talked about. So you don't have to ever create a blank migration and create that field. You can just simply say a vector field, and you can just create the search models. And you can see here, you can say student codes.objects.search, and that actually does a full text search for you. So you don't have to write that ugly SQL, if you may. All right, cool.
What was the GitHub?
I'll come back to that.
Oh.
Okay. So boosting. So this is, we saw just a moment ago, where you boost certain results over other people. So if I want to do Java, I can do on the top. If I want to do still pretty fast, which is over Python, and you again do that with using a concept called TS ranking. So yep. So here, all I'm saying is that if you find in the document a word, just put that on the top. That's all it's doing. It's not filtering. It's just saying that if you do find that search term in that document, just push it on the top above the other people. Because we do that, like you want to boost certain results over other people, you can do that. Or you can put anything you want here. It could be Python, it could be time. Let's just say you want to return documents that are latest documents. So let's just say you have 1 million documents and somebody searches somebody's name, but you want the latest documents on the top. What are you going to do on that? Any ideas? What would you do in that context? So you did a search, you did a TS vector. It gives you all the results of the documents that actually has matching documents, right? So you got, let's just say, 100,000 documents. How are you going to give that to the user? You need to show them the latest results, right? So you need to show them these are the latest documents or the old documents. But well, how would you go about doing it? How would you rank it?
By the created
Created date, right? So that would be one way of doing it.
Or
so
the updated. I would actually go with the updated.
Or updated. So you don't have to use TS rank. You can simply say order by, and then you can give just an updated by date. That's that simple. So it still takes into account the normal order by. So you can just use your typical .order by method in your Django model. It's that simple. So you can use whatever ranking that you feel that you've been using today. You don't have to use TS rank, but you can still just resort to your normal ranking that you would want in your search results. That make sense? Okay. So ranking is a very interesting thing because sometimes you want certain documents to come on over the tops. For example, you want the documents that have title come above the description, come above the tag. I don't know how many people actually have this kind of requirement, but if you ever search in StackOverflow.com or advanced searches that you saw in LinkedIn, they will have like, search for this person in this education field and this specific like sales department, or that's actually my query. I've been looking for a lot of sales guys, but if you're looking for in Stack Overflow for Python to specific to Django, you can actually select that. They'll still give you all the results related to Python, but the Django ones will have a higher relevance ranking because you search for that term. Okay, so what you can do here is you can set weights onto that. Again, all of this is done in Django, so don't have to do this ever again, but I'm just giving it so that you get the idea what's happening.
Like a subset of a bigger search?
Yeah, so you want certain results to come above the other results. That's all you want to do, not the boosting. This is where if you find something in X and you find something in Y, I want the X to come up higher. That's all. Trigram. How many people know n-gram like algorithms? N-grams, trigrams. I've been talking for the last hour, so maybe have you been using it or?
Yeah, I mean it's like the trigram's 3 words or 3
Exactly.
characters, bigrams.
And why would you use that? Just curious.
To find out if there are common phrases together.
Exactly, and that's what it is for. So you basically look for halo, hallow, whatever. People make mistakes in their spelling. So you can see when you do a trigram, which is a very simple algorithm, it breaks down the letters into subset like that. And all it does is it depends on how many letters that match to your search term. So you can be typing in a spelling mistake, and it actually will break those words down and find out how many similar results that you have. And it's extremely fast. I mean, think about it, this is not a like. It's not a regular expression search. You're actually typing in a wrong word. And it actually gives you the words that are actually so close to it in an extremely blazing fast speed. Okay, so to show that, I hope it, whatever claim I made, it works. So that was fast. This is 1 millisecond. So I typed in David, and then the SoundX basically gave me David like that. Because I made a mistake in the search results. So it just basically just gave me something that's related, closely related to it. This happens so many times in our platform that 80% of our searches are actually similarity searches or SoundX searches, literally. So you can tell the state of education, people don't know how to spell in school anymore. Really,
Of course, you got spell check everywhere.
I mean, I know, but still, like, they're searching with incorrect terms. I mean, what?
People are getting lazier.
Yeah, it's just,
Don't have to try
it's
anymore.
amazing. And then that's what we're doing. We're writing so many indexes. We're trying to use so many trigram parsing so that we can give more relevant results. But it's pretty fast. And this is, again, moving through 1 million records in about a millisecond. This is in my local machine. Doesn't have that much juice in it, yet it is running this fast. Imagine if you run it on a full M1 Amazon large machines. All right, cool. So yeah, so the way we use is something the function called similarity, and all it is a probability. Basically, it says if you have 0, it's no match. If it's 1, it's an exact match. So you just have to adjust this every day. So if you look at the my similarity index, so it's 1 to 10. So you can say 1, it will probably give you, these results. And if you say, let's just say, you say 8, it will just give you 0 results because you're trying to. 8 is like extremely tight. Like I want to make sure this word matches 80% of the time. In this case, it doesn't. So you can adjust that. We have a backend where we constantly monitor how many searches are made, especially searches that yielded 0 results. We constantly look at them. We also look at the results that have been returned, but then the student says, I couldn't find what I'm looking for. So anything that triggers off no results or results that students cannot find, we constantly adjust the fuzzy search. And we constantly update our indexes. We add indexes on the fly, and I'll show you how to do that. But yeah, so let's see. And then lastly, I talked about the SoundX, which is the oldest and kind of only works for English names, basically. So my name is definitely not going to work there. And basically what it does is it's the oldest algorithm. It converts the letters into a 4-length alphanumeric character. So you can see here I made a mistake with the E and the extra, but the SoundX comes out to be exactly the same. This has been there in Oracle from day one, so most people would know this. But so with this, it's easier because you can. Almost sounds like it, so that's what SoundX is. You can use that as often as you want. The beauty of that is you can actually bake the entire SoundX into an index itself. How cool is that? So you literally have an index of unique words that you want. So you can actually have an index, separate index. Think indexes as files, like in Solr or in Elasticsearch. Like you can create as many indexes as possible in those search engines. In the same manner, database index is the same thing. It's just a file, and you can have as many indexes as possible. So what we do is we create indexes of unique words. So if we can find it, even after similarities, we go search there and then give them, are you looking for this? So you can see how Google does that all the time, or you go to Yelp, or you go to any other search engines that tell you like, we couldn't find it, but you never want to give 0 results, ever. This is bad for engagement, right? So you always want to give them, we couldn't find it, did you mean this? All the time. It's very critical. So yeah, so that's that. And that code is here as well, because you can see the simple SoundX function. So that just basically takes a term. And again, we're going to be adding to the Django ORM all of these functions, so you never have to actually call these things.
It's not in there right now.
So the only thing there right now is the vector, TS vector. So you can do a full text search right off the bat with what I just showed. But it doesn't have the ranking and the boosting and all the things that I just talked about. So we're going to be adding there soon. And the last but not least, that's the ugly like I was talking about. gonna move this to. So as you can see, this is just trying to search for the first name and the last name and the course name across multiple tables. You don't want to do this ever. Just never do that. Ever don't join multiple tables. You're just going to kill your database and kill the users. So just use a better search engine. Doesn't have to be Postgres. The reason we went to Postgres is time to market, right? So we really wanted to go to the market like yesterday, and nobody in this team knew Search or Elasticsearch. I mean, it just the setup itself is just so difficult. So somebody said just use Postgres, and then here we are talking about Postgres Search. So the pros are obviously, quick implementation, a lot easier to change the document format. Again, create an index whenever you want it. Just don't be hesitating. Speed is definitely comparable to search engines. I mean, it's really fast. Very cost effective because it's one database, one less system to worry about. Like if you try to do Solr, just the console itself is so complicated. It gives you all these bells and whistles, but it's just not the everyday thing you can do. Very cost effective. As I said, it's not flexible, but you can still work around it. It's obviously tied to Postgres, so if you ever switch database, I mean, who the hell switches database in halfway? I mean, I don't see anybody does that, but you could, if you're that brave, please go ahead and do it. And indexes can get large, but that's the case with any other, search engine. So the only issue you're going to find is where Elasticsearch is phenomenal is basically cluster searching, right? So Postgres database is one index or one database. So if you have so many people searching, you're going to get a bottleneck soon, right? So because it's one database. With Elasticsearch, it's shards, so basically all the indexes are spread out. So there's a master, there's a replicas. So basically, if it finds that there are multiple requests coming in, it'll actually try to spread it across. So you actually get really good performance. But not sometimes the master and the replica could be out of sync, but that's actually not a big deal if you really think about it. So
are you talking about using replicated slaves?
Elasticsearch, yeah.
So what about using replicated Postgres?
You could do that too. I mean, you could, like RDS allows you to replicate. I mean, hopefully they'll add that soon, but you can have a sharded Postgres database. But if you're going to go that route, just go with.
Sharded. I mean, you can have a master slave.
Yeah, you can have that too. But I mean, if you're going to go that route, just go with Elasticsearch. Yeah, it's just much, because it's a community that's adding a lot of features to it, very, very specific to search. So it's just much easier to just use when you're gonna go enterprise. So Django ORM, which is this GitHub link, supports full text search right now, literally. So today you can go home and write an index, write a search, and it'll actually work for you today. Okay. The hope is, as we go, as you can see, it's as simple as doing that. So all that gunk you saw with TS Vector and all that crap is all taken care of inside. But obviously it's Postgres. I highly recommend look at other projects under this line. They have amazing like Postgres pooling, which you should always be doing. You should always pool your databases. There's a connection monitoring for your database connections. So it will give you an email if you're above certain connections on your database. But how many of you here actually use pooling in your database? Like really big pooling. What do you use? What do you use?
I can't remember the service.
So connection pooling, are you using? Is it Postgres or is it?
Yeah, Postgres.
Okay. Are you?
I think it's like something with the word bouncer in the name.
Okay, yeah, PG Bouncer.
PG Bouncer.
Okay.
Yeah.
How many of you are actually using RDS or any variation of Amazon databases? Anybody? Like the DynamoDB? Which one?
Use Dynamo.
Dynamo. How is that coming out? Is it fast enough?
For what it does, it's super, super fast. It doesn't do everything,
Great.
but it's super fast.
It's too expensive?
I mean, depends, like most things with Amazon. It's not the cheapest, but it's not,
Right.
it's not bad.
Some of the numbers that they have is amazing. So, the next steps are, add all these things that we just talked about. So our hope in the future, you can do something like this. You can say .search, we know how Django programmers like to see their code. So object.search, then do a rank, then do fuzzy search, then do soundex, then do a rank, and stuff like that, which is very Pythonic, which we all love. And then I'm going to continue to add code to Postgres search so you guys can take a look at it. So what I did is it actually is a full end-to-end. So it has AngularJS at the front end, Celery at the back, Django 1.6 I think, and uses Stout. So some tips. If you can use a separate DB just for indexing. You don't have to use the master database first of all. You can do that. You can literally just separate it out and put it on a different machine altogether if you want to. It'll always feel like is an engine. This is very important. Don't index everything. 3-letter words. You don't want to index everything. You want to limit your indexes. So, for example, if you have 1 million users, out of which 5 of them are active, which is the case with all startups today, you don't want to index everybody, right? So you want to index only those people. So you can actually, while you're creating an index, you can say, create index where the user date is around a certain time, which could be like today's date or like a date minus 30 days, or something like that. So you can only index those people who are active in the last 20 days. The cost of that is index going to get updated constantly, but which is not that bad because it does it very well. It's happening in the backside. While people are reading the index, they're going to continue to get the old results while it's updating the index. So which is still okay with it. I'm fine with that. And you can use Postgres Analyze and TSStat. This is what we do now a lot, which is we create indexes concurrently. So what happens is a lot of times we know there are new search requirements. People say, hey, we want to search on this, search on that, but we don't have indexes for it. So what happens is we sometimes see this, which scares the hell out of us, which is this is literally the cost to run if we don't use an index. And I don't know how many of you actually do explain plans on databases, but every database comes with that. But the cost is pretty high, literally, this is very high. You can see it tries to do a lot of hash conditions and goes on and on and on and on until there's a sequential scan, which is horrible, and then another sequential scan, which is another horrible thing to do. So when you see this, you got to be like getting up and running somewhere because this is not good. So what happens if you use a simple TS3 vector? Pretty nice. It uses bitmap heap scan, which is pretty fast, like dopey fast, and the cost is just barely anything. So it's really, look at that time. That's 1 million records right there, 0.5 milliseconds. You can't beat that. The rest of the time is spent in Django and AngularJS. So really, this is the time spent by the database actually. So what you saw at 1.2 or 0.8 milliseconds, that's all just Angular and Django doing their list comprehensions or whatever the hell they do. So
List comprehensions are really good.
yeah, no, I know they're pretty good, but they're at time to the overall execution. So, and the last one is don't pull your foreign key objects in your searches. Don't do that. There's no reason why you should be pulling that. That's why we have a title. So use a title, which is a document title, to show the users what it is, and concatenate or put IDs in there and make a URL out of it, right? So when I'm doing this in this screen, this. So this comes directly from that single table. What I have there is student ID. I can actually prepare a URL using, I know the URL, right? I can say /student/ID. I can prepare the URL. So there's no reason for you to pull, when you're doing searches, never pull additional tables. Never, don't do that. It's not healthy. So just try to like concatenate. So put in enough information like IDs in your database in that table so that you can actually concatenate and create IDs. And that's what you do with your Solr or Elasticsearch. In Elasticsearch will ask you, or Solr will ask you, what is the data that needs to be searched, and what is the data that you need to store, so that when I actually find it, I can give it to you. And you usually would add things like ID of the student, ID of the course, ID of that. That's what we're trying to do here. Does that make sense? Okay. And so that's me. And you can reach out to me anytime you want.
That'd be why.
So
I've been trying to get to that, but I couldn't find it.
sorry, but yeah. So hopefully all you guys use Postgres because there's no reason why you should not use Postgres. And don't use MySQL, and don't use Mongo. But you should use Mongo. I use it for mostly for chatting and data that I don't care about that much. At least not transactional. But it's a RDS. Hopefully adds more, as you said, replica and slave, and read-only replicas, which will be even better. It's a little expensive, but as long as I'm not doing DevOps, I'm more than happy to do so. So, any questions?
Wait, so like concurrently, do you use Django ORM to build your tables, or are you custom building your create tables?
So Django ORM does some of the building. So if you use the South, it actually will create a TS vector field.
But like the concurrently for indexes, it won't do that.
Oh no, concurrently you have to do it, because you have to notice it yourself, because you know what fields you're searching on, right? So all you have to do is you just have to create another index which has that subset of data, basically.
So what's an example when you apply concurrently? Like, so basically you let the indices be the basic stuff, the keys, right?
Yeah.
So when do you bring in concurrently? So you're saying you look at the explain plans and you see something's being hit. But you're not going to use a regular index. I'm trying to figure out when would you use concurrently.
So if you want to add a brand new index on a different search term, so another field maybe. So for example, we have another table that actually has the data that we're looking for. So we want to bring it into a document, then we're going to redo the index itself, or we to recreate a brand new index. So the old searches will still function. You see what I'm saying? So at that point, when we create that index, so it will try to what Postgres will try to do is it will try to look at what index is available, which index is more cost efficient, and it will use accordingly that index depending on how depending on the cost that it calculates. Does that explain it?
But what made you decide to make something a concurrent index versus
because you don't
regular?
want if you try to update the index, they won't use index. It will just go to table scan basically. It will just completely ignore your TSV vector, or it will just not work at all. Because when you
default one block while it's building the index.
Yeah, so
yeah.
so you can't. I mean, with concurrently, what happens is it's a read only at that point. So indexes still can be read, but it will still be old data. But
Right, so you introduce a lag, but then you get faster.
Yeah,
So
it's just that you don't have a downtime basically.
So would you not, if you're not worried about having stale data every little bit,
Yeah.
why wouldn't you always say do concurrent then?
Because this is while as if we are in production, right? So let's just say we are going to production today or tomorrow, then you don't need to run it concurrently because you don't have any data. If you are, you should. I mean, in that context, yes. Like if you are in production, if you are actually running data, if you have 1 million records, more than 10 records for that matter, you should always be using concurrently, of course. But this is saying that if you're building something, right, you don't need to use concurrently. There's no reason to. Because you already built the index, and then it'll just update it. Because Postgres will update that automatically every time there is a new record that's been added to it.
But even like you said, like as it's updating it, it's gonna be slower if it's a regular versus concurrent because otherwise, for the right to complete the transaction to close, the index has to get updated too, right?
Yeah, but it does it automatically.
I think it's when you're building the index. When you
So if you want to build a brand new index, or if you want to
okay, so it's only if you're building a new.
Yeah,
index
yeah,
that
absolutely. I'm
you
sorry, I wasn't clear on that. Yeah, so it's only when you say create index concurrently, that's only when you're building a brand new index. But when a record is updated, let's just say you add a new record and the index has to be updated, Postgres takes care of that.
Alright, so it's no big deal. Then.
That makes sense?
Yeah.
That Twitter handle goes nowhere.
Oh, Agile Seeker? Oh, I misspelled it and right away. So my bad. I didn't do a search on that. So it's
Nice name.
Agile Seeker. So
You should change that. That's a really cool name.
Agile Skier. I should like that too.
So you need a fuzzy search.
Yeah,
on
we need a
Twitter.
fuzzy search on that for sure.
No, keep it. Like, just make that your new Twitter handle.
I know, right? There we go. Sorry about that.
Part of me wants to steal it.
Yeah, please go and knock it out. Any questions? I mean, how many of you actually have? I'm sorry.
So on the demo, you had like 3 different searches, right?
Yep.
So full text, some text, and something else.
Yep.
So if you misspelled something and then did full text, it wouldn't.
Yeah, I
find,
wouldn't
right?
know that, right?
Okay.
I mean,
how can you combine the two? Like, I want to have a surge that does everything.
yeah, it does, right? So, I mean, okay, so that's a good question. So what you want to do is, and this is what we do, is when we do a full text search in the beginning, we see if there's no results that came out. We
Okay.
go to unique index and see if there's any matching words for that, and then use that search. And if that doesn't come out, then we go to Soundex.
Okay, so it's chain.
Yeah, it's a chain because, and it depends again. Like the entire premise is based on you do not want people to see blank results, right? Because that is horrible because then there's engagement and all that fancy metrics are there. So yes.
Does it ever take into account like keyboard, the key position? Because sometimes like I'll type a word, I'm not looking, and I'm completely shifted over like one. Something like at some point I get shift over.
Could you give me an example? I'm sorry.
No, like when you're typing without writing.
Yep.
You might like press the key next to it.
Right.
Does it take that into account?
So that there's an algorithm for that. I hope I'm pronouncing it right. Levenstein theorem. So it finds out how many edits does it take to replace one word with another word. So a smaller length is very comparable, and like as the distance grows higher and higher, it's not very similar. So is that answer your question? So is that what
it's
I'm?
Not like mistyping one letter. It's mistyping a
few
letters all like in order.
Yeah.
Like,
So exactly. So
yeah.
so you compare that against
But they're
unique
all
words.
off by like one. On
Oh,
the
you
keyboard.
literally just like it doesn't
like
make any
shift it
sense at
over.
some point. At that. Yeah. So that's why you use Levenstein's or theorem. But it finds a number of edits it takes to replace one string with another string. How many of you guys know that?
Right, no, I don't think that's what she's
Would?
talking about.
Okay.
Yeah, that's not.
She's talking about if your hands, when they're typing,
Oh, you're literally
are
just
fully
like
offset,
this?
Offset, yeah.
Oh, offset. I don't know. I mean, you probably will give completely random results because the Soundex or the
not
similarity
sound
would be not even close at all.
Like each letter would be off by.
Yeah, so because the vocabulary will change, I mean the way the word sounds will change and the similarity will change. It's not that smart, sorry. I wish it was.
Yeah, like that would be cool.
Yeah.
Does it have support for like Boolean operators? Like if I was
Yes,
saying
absolutely.
not-
I'm so sorry I didn't mention that. It absolutely supports Boolean operators. So if you look at the, thank you for bringing that up. If you look at the Django thing, if you look at the search, these are all OR operators. You can use ampersand, or so you can actually have multiple words concatenated. If the user searches like I want pizza, whatever, you can actually tokenize that, or you can use plain to query, or you can actually use yourself those things if you wanted to.
All the regular expressions.
So you can support. So Postgres has regular expressions built in, right?
Yeah.
So you could, which I didn't cover because at that point it became a Postgres conference. So, but there is support for regular expressions. It's freakishly fast too. So if you, again, as I said, thanks to Russians, they build that regular expressions pretty fast. So you could use that. You can bake that into actually index itself if you wanted to. So there's a very good documentation available for that too. I think 9.3 comes standard with these modules right now. So you just have to create extensions based on that.
So what do you use, like, as you're developing this stuff? You write the Django code, you think your query works, then you run it in Angular in your front end. You're like, I don't know. So what's your typical approach to actually see what SQL is generated?
So we use the we used to use the Django debug toolbar, so which doesn't work with Ajax. I don't know if they still fixed that issue or not. Have you guys? Is that still an issue? Because apparently it doesn't spit out queries when you do Ajax calls from Angular, or for that matter, just Ajax. There's no account of that. But we print our queries, so we have middleware that actually prints out, if you're on dev stage, dev mode, it prints out all of these SQL queries that are been executed.
It's just the logging level of
Yeah, it's the log, yeah. So it's a
your
middleware that like, looks at the
settings,
connection
kind of
that queries and simply logs to the right log file.
Okay, you just tail that, whatever.
Yep. And then we take that and we see if there is any results that didn't come out through. So we have another interface that is a Node.js interface, which basically what it does is every time there is a record that was not found, it pings, it creates a ping to the node and just says, look at this query. So we store that query itself into the database, and we'll say, but first of all, we push it to Celery, and the Celery goes to Node and says, sort it in the Mongo, and then we look at that and say, oh, this query did not return results. what the heck's going on, you know, and then we kind of look into that. So is it data that didn't exist, or is it simply because the user typed in something wrong? So yeah. Anything else?
I can't help but ask, but so you got obviously using Django Python, now using Celery, I get that. So why using now Node.js? What's that bringing to the table?
So we use Node for real-time chatting. So because we've been talking about it for such a long time, can we move that into Django? But I don't know whether people haven't experimented enough, I guess. But we use Node for mostly real-time notifications. So Node such as chatting, like we use one-on-one chatting, group chatting, notifying browsers. So there's a new post is available for you to view. So it's like keeping those ports open. So we run on a separate subdomain such that we can push the browsers and say you have a new post, or you have a new user who is in the same cohort or something like that.
There's I don't know if you've heard about it. I actually learned about it at TechCrunch Disrupt Hackathon, Parse.com.
Yep. Yeah, Parse is great. I mean, I highly recommend use Parse. So Parse is how many people know Parse here?
It's actually got more power than it.
Yeah. So I definitely.
It's a NoSQL database in the cloud, basically.
Right. So we use Parse for notifications for APNS and Google GCM notifications. So such as you get push notifications on your phone. It's extremely it's very cheap. So and it's a REST API. So it's basically
free
just
for most uses.
So you just basically do a REST API call with the user ID, and you get push notification for that. So, but I mean, if you want to use like real time, use Firebase or Pusher. How many of you guys know Pusher? Pusher.com. If you go to Pusher, it's pretty good. It's all JavaScript integration in the front end. You don't ever have to do anymore like the way we did with Node. So just use Pusher.com. It's amazing. All you're gonna have to do is authenticate your user with Pusher, and
does Pusher provide Facebook and Twitter?
You're talking about iOS integration, right? Or you talking about just
Facebook and Twitter authentication?
Yeah, but that's just Django. What is that? Django authentication is available right now. Which does SocialAuth. Django SocialAuth does all that. So
Parse.com gives it for free.
Yeah,
and
but
you get push notifications.
Yeah, but I mean, I'm just saying browser notifications, a browser chat.
I think can't you do that with Parse or not?
I don't know. I don't think so, because it's purely SDK, iOS and Android SDK. But it could. I mean, everybody's doing it now, so it's just a flavor, right? I mean, anybody can know Node basically does that. So I won't be surprised if they do it.
Sorry, I'm just curious.
Yeah.
I just learned about it.
Sure.
Okay, well, that sounds like a lightning talk for next time.
No, I don't know enough.
All right. Well, thank you very much.
Yeah.